Today we're going to review functions. So the first thing is when looking at a graph, how to identify everything. Domain is the farthest left and right a graph goes, and range is the farthest up and down a graph goes. Increasing and decreasing, is it the x or the y values? It is the x values. That's the very common mistake, especially on the SOL. They will give you the y values trying to trick you, but you have to remember that it is x. The vertex is the ordered pair at the very bottom of the U. So like if we were going to look at the U down below, the vertex would be right there. So for the first example, to find the domain and range, domain, you drag your pen across this graph. You have to remember that this graph keeps going. So use your imagination or extend those ends. And when you drag your pen across, it will be touching the whole time. So that means the domain's -infinity to infinity, or they may write it as all real numbers. Who knows? They may just write all real numbers, like all the words. For range, you drag your pen up. So when you drag your pen up, you won't be touching it until you get to right there at the very bottom of that vertex. So the first time you'll touch it is the y value of -6, and then it's going up until infinity. Or you could write it, or they may write it, as all real numbers greater than or equal to -6. So for increasing and decreasing, you travel left to right like you're reading a book, and you ask yourself, where is it going up and where is it going down? So for increasing, if I go left to right, I would be going up in this section right here. Always using x values, so you should not be using -6, but the x value right there, I would say is maybe 1.5. And then it keeps on going to the x values of infinity. Then for decreasing, it's decreasing on this portion of the graph. So this portion of the graph is coming from -infinity, because if you look, this side is in negative values for x's. And it stops at the x value of 1.5. So then for end behavior. So this first end behavior is talking about the right-hand end, where x is going to infinity. It's talking about the right-hand end right here. So in that right-hand end, I drag it to the y-axis, and the y values right there are positive numbers, so it's positive infinity. The next one is talking about the left-hand end right here. The left-hand end, when I draw it to the y-axis, is also in the positive y, so it's positive infinity. All right, the second graph. This graph is a little funky because of the asymptotes. So how you write domain and range for these is you write the r, the real numbers, and not equal to, because it's everything except for where those asymptotes lie. So for domain, when I drag it across, I'm going to look at that asymptote that's crossing through the x-axis because it's x values, so 3. For range, I drag my pen up, and it's wherever it is crossing the y-axis right there at 2. So then we ask ourselves, is it going up or down whenever you travel left or right? Generally, these either go all up or all down. So in this case, it is not going up at all. However, it is going down. It's got to be doing one or the other. So this is going down, and that is going down. So I write none for increasing. And then for decreasing, if it's only going up or only going down, since increasing and decreasing is only x values, that means the little trick is that you're only just going to copy the domain down, because domain is x values. End behavior. So both the right-hand end and the left-hand end there's asymptotes. They're flattening. So that means it's going to be the number that they're flattening at. So this end right here is flattening at that y value of 2. Same with this end. It's flattening at the y value of 2. The next thing is compositions. So this is when you substitute one function into another. So usually it's written like this. However, sometimes it's written like this. So f, an open dot, g, x. So please do not be thrown off if you see that on the SOL. So the first one's asking you to take g and plug it into f. So I'm taking g and I'm plugging it in for this x right here. So it's going to look something like this. So if my f function's read, I'd have 3, but then I'm plugging in 2x plus 1 for the x, and then squared. You are going to have to simplify this one, and there's one just like this on your worksheet today. So how I would go about simplifying this is to square that 2x minus 1. Unfortunately, I do need to go off and do the box method for 2x plus 1 and 2x plus 1. So that would get me in the first box 4x squared, second box 2x times 1 is 2x, third box 2x times 1 is 2x, last box 1 times 1 is 1. So then I would add my diagonal. So I would still have that 3 on the outside, but then I would have 4x squared, add the diagonal, that gets me 4x plus 1. Last step, distribute the 3, so your goal is to get rid of the parentheses this time. So I would have 12x squared plus 12x plus 3. That's my final answer. That's what they would have on the SOL. Next example. This time it has numbers. So when there's numbers, I plug 3 into the g function. So I plug 3 into the closest letter to the number. So the g is closest to 3, so I plug 3 into g. So you can use your calculator or your brain, but basically you're plugging 3 in for that x right there. So 2 times 3 plus 1. So 2 times 3 plus 1 gets me 7. So then, after I do that, I plug 7 into f. So I plug right there into this x. So 3, 7 squared. Again, just type it right in your calculator. If you did that, you get 147. Next is asymptotes. To find vertical asymptotes, you factor the denominator if you can. If you cannot, then you just set the factors, or what you have, equal to 0, and you solve. So I'm going to go down to my example right here and find the vertical. So on the bottom, x plus 5 cannot be factored. So I just set it equal to 0, and I solve it. So when I set that equal to 0, I would subtract over 5. So my vertical will be x equals negative 5. You must have an entire equation. So x equals or y equals. I do that because they will throw in the SOL y equals negative 5, and if you pick it, it will be wrong. So I need you to get in that habit. For horizontal asymptotes, that's when you compare the exponents. So there's 3 different cases in this. If it is a bigger exponent on top over a smaller, then the answer is none. If it is a smaller exponent over a bigger one, then it is y equals 0. If it is the same, you divide the leading numbers. So in this case, there is no x up top. If there is no x up top, that means the exponent is 0. On the bottom, there is an x, and the exponent's 1. So 0 is smaller than 1, So it's a smaller over bigger, so that means the horizontal is y equals 0. Last topic is inverses. So what you have to do inverse is switch the x and y and solve for y. Commonly, they use the notation f -1x, and if you don't know what that means, then you're going to be out of luck. So make sure that you know what that means. So in this example, I switched the x and the y, so it'd be x equals 5y plus 10. Nothing else switches except for the x and y. Now I solve for y, so I'm going to subtract over the 10. So that gets me x minus 10. Now I divide by 5. When I divide by 5, I have to divide the x by 5 and the 10. So that's going to give me x divided by 5 minus 10 divided by 5 gives me 2 equals y. That's my final answer. All right, so now go ahead and do your Socrative quiz.